As you've probably learned by now, there are multiple ways to approach the Pandas library for a specific task, and selecting rows is no different. Here we will learn two ways to select rows using the index. The first is by using the index location, and the next is using the index label. While I don't recommend using numerical values for selecting columns, numerical values can be very helpful when selecting or slicing a subset of rows. For example, in our projection model, there will come a time where we need to skip the first row, but select the next 10 rows of a data frame. Rows can be selected by passing the index location as an integer location to an iloc within square brackets. So really, this is extracting rows based on the index position and location. Let's look at an example with our data frame. And like before, we are going to take a subset of our data frame and we'll sample 20 rows. And just for fun, let's see who we got. Big Klay Thompson fan here. So if we wanted to select a specific row in our data frame, we use the I location, much like the columns. However, this time we're just going to pass it a row number, and let's pass it 8, which would give us the 9th row of the data frame since it starts at 0. And since we aren't passing it any columns, it will give us every column. And again here, we get it returned as a series since it's just one row. And this is Taj Gibson, so let's just make sure Taj 1, 2, 3, 4, 5, 6, 7, 8, 9. It's the 9th row, even though it's 8 since we started 0. Great. The nice thing about Pandas is that each data frame has index positions even if they aren't explicitly called out in the code. If we had custom index names, we could still extract rows based on the index position. As always, the index position that Pandas provides starts at 0 and counts up. So let's say we wanted to select multiple rows. We can do this by slicing it with our slice operator. So like I said, if we wanted to skip the first row, so we'll say start at 1 and then take the next 10, so include up to the 11 minus 1 row. This should now return 10 rows of our data frame skipping the first, and let's just save it in a df to print. And voila, we skipped our first row, which was Michael Beasley, and then took our next 10, ending in Marvin Williams. The other option that I mentioned earlier was the close relative to integer location, and that's just good old plain location, which uses the index label. It behaves identical as it is called directly on the data frame, but this time, instead of passing the integer position, we pass it the name of the index label. So since our index label is currently just numbers and integers, let's go back into our old Lakers dictionary and build a data frame. And we'll give it a custom index with specific string values. So let's say within our data frame, again, if we just print it, here is our data frame. Let's say we wanted to use the location and get the small forward, which would be Brandon Ingram. We could pass in df loc, and then within the square brackets, the SF, which is the index label. And if we ran that, we would get a series returned from just the row, which was Brandon Ingram. And like before, we could also get multiple indexes. So let's say we wanted the power forward and the point guard. And we run that, and we'll get a data frame with just the rows that are power forward and point guard.